Today's AI safety mostly works by showing a model thousands of examples of good and bad answers, hoping it absorbs the rules by pattern matching. But the model never actually reads the rulebook. This paper from OpenAI, the one behind the O1 reasoning models, tries something different. Teach the model the safety rules and let it reason through them before it answers. The authors pinpoint two flaws in how we train models to be safe today. First, the model has to answer instantly, with no time to deliberate, even on a tricky, borderline request. Second, it only ever infers the safety standards indirectly, from labeled examples, instead of learning the actual rules. That makes it brittle against anything unfamiliar. Deliberative alignment fixes both. The model is taught the actual text of the safety policies and trained to do something humans do naturally. When a request looks risky, stop, recall the relevant rule, and reason through it in its chain of thought before responding. Safety becomes a thing the model thinks about, not just a reflex. Here's it working on a real jailbreak. User hides a shady request inside ROT13 ciphertext, hoping the model decodes and obeys without noticing. In its chain of thought, the model quietly decodes it, realizes the user is trying to trick it, checks the policy, and refuses. It caught the trap by reasoning, not by reflex. So how do they train this without armies of human labelers? The whole pipeline runs on model-generated data in two stages. First, supervised fine-tuning teaches the model to reason about the rules. Then reinforcement learning sharpens that reasoning. Let's unpack both. Stage 1 is clever. They take a model trained only to be helpful and hand it the safety spec in its prompt. It writes out answers that cite and reason over the policy. Judge model, also given the spec, filters for the best ones. Then, crucially, they delete the spec from the prompt before training, so the model learns to recall the rules from memory. Stage 2 is reinforcement learning. The same judge model, armed with the safety spec, scores the model's answers and rewards the good ones, so it learns to reason more effectively. One careful choice: during RL, the judge never sees the chain of thought itself. That avoids pressuring the model into writing deceptive reasoning just to please the grader. And here's the quietly radical part. None of this needs human-written answers or chain of thoughts. The data is entirely model-generated and model-filtered. That matters because as models get smarter, fewer humans are even qualified to label their outputs. This pipeline scales safety alongside capability, instead of bottlenecking on people. Does it actually work? On a tough jailbreak benchmark called Strong Reject, GPT-4o scored about 37%. The O1 model jumped to 88. And it did this while refusing fewer harmless requests, not more. Usually safety and helpfulness trade off against each other here. Both got better at once. This chart captures it. The vertical axis is not overfusing harmless prompts. The horizontal axis is resisting jailbreaks. The best models sit in the top right. The O1 models, the green stars, push past GPT-4o, Claude, and Gemini, advancing the frontier of being both safe and helpful at the same time. It's not just refusing more. The rules include a third option beyond comply or refuse, called a safe completion, for sensitive cases like self-harm, where a blunt refusal could itself be harmful. And following those delicate guidelines, the jump was dramatic, from 4% for GPT-4o to 92% for O1. Because safety now runs through reasoning, something neat happens. Let the model think longer, and it gets safer. Give it more inference time compute on the hardest jailbreaks, and its scores climb. The authors frame this as the model being right for the right reasons, not just guessing a safe-looking answer. Which part does the work? They ablate it. Safety in supervised fine-tuning alone, or in RL alone, each helps partway. You need both. Fine-tuning builds a strong prior for safe reasoning, and RL teaches the model to use that reasoning well. Notably, training it in beats just pasting the whole rulebook into the prompt at runtime. The most striking finding is generalization. They trained a model with 0 non-English and 0 encoded safety examples, then attacked it with exactly those, jailbreaks in other languages, and in base 64. It held up almost as well as a model trained on everything. Learning the underlying rules, not surface patterns, transfers to attacks it never saw. So what's the big picture? Don't just train a model to act safe, teach it the rules, and let it reason over them. That makes safety more robust to jailbreaks, less prone to needless refusals, and able to generalize to new attacks. It even scales with thinking time. Reasoning, it turns out, can be a safety tool. That's deliberative alignment, making AI safer by teaching it to reason. If this helped, subscribe and tell me which paper to decode next.